So we've got the two circles C1 and C2, and they intersect at A and B. So the first thing we're going to try and do is work out the coordinates of A and B, and those are where the two circles intersect. So we're going to solve the simultaneous equation where C1 equals C2. So over here on the left, I've rearranged C1 to make y squared the subject. Y squared equals 100 minus x squared, which I'm calling equation 1. And then I'm substituting that into equation 2. Yeah, that's not very clear. Equation 2 is actually the lower one, isn't it? Equation 2 is this one here. I think my slides just slipped. So I'm substituting a rearranged equation, the x squared plus y squared equaling 100. I've rearranged and I'm subbing that into the x minus 15 squared equation, which I've done over here on the right. So I've then got to multiply out the x minus 15 all squared. The x squareds cancel out. Rearrange it, I get 30x equal 285, so x equals 9.5. So my x coordinate for A and B, so the length from O to D, is 9.5. Now I'm then going to substitute that back into either C1 or C2. I've substituted it back into the rearranged C1, the y squared equals 100 minus x squared, to work out what my two y values are. So subbing that in, I get the y coordinates are plus or minus root 39 over 2. So obviously at A, it's the plus root 39 over 2, and at B, it's the minus root 39 over 2. I'm then hooking out the triangle, the right angled triangle, A to O to D. Okay, A to O to D. Now I've worked out the x coordinate was 9.5, so the length from O to D is 9.5. Let's just make it clear which this is O, this is D, and this is A. So the length from O to D is 9.5, and from A to D is the root 39 over 2. Okay, that's the x coordinate and the y coordinates. I've got a right angle triangle, so I can just do bog standard SOHCAHTOA tan alpha, alpha being the angle between A, O, and D, equals opposite over adjacent. That gives me my value for alpha of 0.317. Now the question is asking for angle A to O to B. So that's two lots of the angle from A to O to D, which I've called alpha. So I'm just doubling my 0.31756 to give me my 0.635 as required in the question. So for part B, I'm being asked to work out the perimeter of the shaded region. So that's going to be this arc on the C1, which I've done in yellow, added together with the orange arc on C2. So work each of those out independently, add them together, and I get my answer. So let's start off with the yellow arc. So this is the major arc on C1 going from A to B. Now remember, the length of an arc is r times theta. Now r is the length of the radius. Now I know the radius for C1 is 10. Remember how the equation of a circle works. X squared plus y squared equals the radius squared. So the radius squared is 100, the radius is 10. So my radius is 10, then I need the angle, this big angle here, okay? The not alpha, not angle AOB, but this exterior angle here, this big reflex angle here. Now 360 degrees is 2 pi. So the angle that I want is 2 pi take away that angle AOB from part A. So 2 pi take away 0.635. So just make sure you understand where the angles come from. So it's just r times the angle, 10 times the angle gives me 56.48. So that length in yellow is 56.48. Okay, now moving on to the orange arc, so the major arc AB on C2. First of all, I need to work out what the angle from A to E to D is. So I've just hooked out this triangle over here to help me gather my thoughts. A to E to D, and I'm calling that acute angle beta. Now I know the length from A to D is root 39 over 2. I'll work that back out over here, right at the beginning. And I know my length from A to E. A to E is the radius of the C2. So looking at the equation for the circle C2, r squared is 40. So my radius is 40. So A to E is 40. A to D is root 39 over 2. So I'm now using sin here. Sin is opposite over hypotenuse, so root 39 over 2 over root 40, and that allows me to work out the beta. I've called it theta there, I should have called it beta, shouldn't I? Let's just change that. So beta equals 0.516. So that's the angle from A to E to D. So A to E to D is 0.516. So the angle from A to E to B is double this, which is 1.033. So that's that acute angle from A to E to B. Now again, I'm just going to use the length of the arc is r theta. The radius is root 40, so my r is root 40. And my theta, again, remember, I want this major angle here. So that again is 360 degrees 2 pi. Take away that 1.033. So r is root 40. My theta is 2 pi. Take away the 1.033. Multiply those together. I get the length of the orange arc being 33.21. So my final answer is the length of the yellow arc, 56.48, added to the orange arc, 33.21, giving me a final answer of 89.7.